Hi, and welcome to this video on compound inequalities. Okay, so compound inequalities. There are two types, and the first one that we're going to look at is called intersections. Okay, so the first type of inequality that we're going to look at is called an intersection. The other type is called a union, and we'll look at what that means later. So we have two types, intersections or unions. Okay, well, intersections are inequalities that contain the word and. So that's the key word. Anytime you see the word and, that means that you are dealing with an intersection. Well, what does an intersection mean? Well, an intersection is true only if both inequalities are true. So what happens is you have two inequalities combined together, such as in example 1. We're going to look at that one. And so when you see an inequality written like this, you can assume that it means and. The other type of inequality will contain the word or, but you will never see it look like this. So when you see this, this means negative 2 is less than or equal to x minus 3, and x minus 3 is less than 4. So what happens is I'm going to take these apart and solve them separately. You can solve them together, and I'll show you how to do that in a minute. But first, let's solve each one of these separately. Okay, so we learned how to solve inequalities in the previous lesson. So in this case, I know that I'm going to add 3 to each side. So plus 3 plus 3. And when I do that, these 3's will cancel out. So I'm left with 1 on this side is less than or equal to x. And in this second inequality, I'm going to add 3 to each side. So plus 3 plus 3. And in this case, I'm left with x is less than, it looks like 7. Okay? So if I were to rearrange this, remember that we said the inequality symbol should be, the variable should be on the left. And so you have x is greater than or equal to 1 if we write it that way, because if 1 is less than or equal to x, then x obviously has to be greater than or equal to 1. Okay, so let's say that I want to separate these into two graphs. So I'm going to graph the first one. And so we know how to graph a single variable inequality or a single inequality. And so I would have 1 here, 2 here, and maybe 0 here. And so I'm going to have a closed circle at 1, and it looks like it points to the right. So it points in that direction. Well, let's say that I'm also going to graph the second one. And so this one will be at 7. The next number will be 8, and the number before it would be 6. And so I'm also going to graph this one, and this one I'm going to start at 7, and 7 is not included, and that's going to be open, so this one is going to point to the left. Well, let's say that I wanted to combine these. Oops, I lost my graph there. So let's say I wanted to combine these onto one graph instead of graphing them with two graphs. Okay, so I'm not going to use this anymore. I can put all of this on one graph. So I know that I'm starting that 1 is in my solution set for the first inequality, so that's 1. And then over here somewhere I have 7, so let's count. So before 1 came 0, 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, oops, I need to count one more. 7, and then 8. So 0, 1, 2, 3, 4, 5, 6, 7, 8. And so I have both numbers there. So let's graph the first one. So the first inequality was x is greater than 1. So I can take this inequality, instead of putting it by itself, I'm going to put it on this graph. And so x is greater than 1, greater than or equal to 1. And so 1 is included in my solutions. And so what's going to happen is I'm going to shade that in and point my arrow to the right because it's greater than or equal to. The next one, let's try orange. 7 is an open circle. And this one is less than, so it points to the left. Right? And so it goes that way. Well, what I'm looking at, what I'm really interested in is what my inequality is doing between these two numbers. Okay? Well, I can see that 1 is less than what my inequality could be. Like 1 is included in my solution, 2, 3, 4. And of course, all the decimal points in between there, up to 7, but it doesn't include 7. So if I wanted to write this as a compound inequality, let's say that I left it like this. 1 is less than or equal to my x. But what else do I know about x? Hopefully you guessed that x is less than 7. So I'm going to bring this down. So x is less than 7. So what I get is a compound inequality that is between 1 and 7. It's including 1 because it's less than or equal to x, right? So as I can see here, my inequality includes 1. And so it also could contain any of these solutions in here represented by x up to less than 7. So that could be 6.9999999, but not quite 7. Okay? So what I get is a compound inequality where I have solutions that satisfy both of the inequalities contained here. So what does it mean that both solutions have to satisfy the inequality? Well, the solutions for x is greater than 1 have to satisfy the inequality, and they do whenever x is greater than 1. However, solutions that are where x is less than 7 have to also be true in order for the inequality to be satisfied. So what I can see is that here, because only one inequality is satisfied, I only have one colored line here, this part is false, and because I only have one colored blue line here, this part is false. But where my inequality contains 2, for instance, including 1 all the way up to less than 7, then my inequality is true because I have 2 lines, because both of my inequalities have solutions in this region. So what I'm looking for is a place where both of my inequalities have solutions. Okay, so I hope this was helpful. I'm going to give you guys some time to try the next example. So go ahead and pause the video and try example 1 and 2. Okay, so let's try example 1. In example 1, everything is already separated for us. So sometimes you may see the inequality written as this one above, or sometimes you may see it written as in number 1 where it's already been separated and it says and. Okay, so we have y minus 3 is greater than or equal to negative 11. So let's solve that. I know I need to move 3 to the other side by adding it. And so y is greater than or equal to negative 8. And then I also need to do the same thing in the other inequality. So plus 3, that cancels, and so y is less than or equal to negative 5. Okay, so in this example, I have y is greater than or equal to negative 8 and less than or equal to negative 5. So I no longer need to try this by putting it on 2. I can go straight to this graph and put it on 1. So let's draw this graph. So here's my number line, and I know I have values at, we know that if I start at negative 5 going this way, negative 6, negative 7, negative 8, negative 9, and maybe over here I have negative 4. Okay, so y is less than or equal to negative 5. Well, negative 5 is here. Less than or equal to shows me that I have a closed circle. So there's that circle, it's closed. And so I know it points to the left because it's less than or equal to, so it's going that way. Okay, then I have another closed circle at negative 8, and all the values greater than it, they point to the right. So what I'm interested in is where I have solutions that satisfy both inequalities. Well, that would be between negative 8, including negative 8, and negative 5. So from negative 8 to negative 5, so here, including those values, my inequality is true. But before that, my inequality is false because it only satisfies one side of the inequality. And on the right side of negative 5, or no, for numbers bigger than negative 5, it only satisfies one side of the inequality. So my solutions, if I want to write my compound inequality, are satisfied. So we're going to write the compound inequality just like it is up here. So it looks like the smallest number is negative 8. So negative 8 is less than or equal to y. In this case, we're using that for the variable. So my solutions can start from negative 8, and y can be anything in between negative 8 all the way up to negative 5. Okay, so this would be my compound inequality. That's how I write it. And so this is just the graph of what I just wrote. Okay, let's try number 2. So number 2, I'm actually not going to take it apart. Remember I told you that you could split them apart and you could write negative 6 is less than or equal to r plus 7 and r plus 7 is less than 10. You can continue to do that if you would like, but I'm going to also show you in this example how to solve it all together. Okay, so we don't always have to separate it. We understand that it's and, that this is really 2 inequalities that I'm solving. So in that case, if I have 6 is less than or equal to r plus 7, I know that I want to get r by itself. R goes in the middle, so I want to isolate r by itself so that I can compare my inequality values, or the limits of my inequality. So I'm going to subtract 7 from this side, but I also have to subtract 7 from the left side, and I also have to subtract it in the second inequality on the right side. So I have to subtract 7 3 times, 1 to create the 0 pair, 1 for the first inequality, and 1 for the second inequality. So when I do that, I'm left with r in the middle by itself. I have less than, over here I have less than or equal to. So when I combine these, this is negative 1, and when I combine these, this is, it looks like 3. 10 minus 7 is 3. So let's graph this inequality. Okay, it looks like my limits are from negative 1, then 0, 1, 2, 3, 4, and over here maybe I can add a -2. So I'm going to graph my inequality. So it looks like it's less than or equal to when it's compared to -1, it's including -1. And so if I'm concerned about how to graph this one, -1 is less than or equal to r, but it doesn't mean that my arrow is pointing right. Remember that in order to graph and to understand your graph, the variable has to be on the left. So let me reverse the inequality to make sense. On the graph, r is greater than or equal to -1. Therefore, this inequality should be pointing in this direction. Okay, so if you have trouble seeing that, make sure that you always reverse the inequality if you have trouble graphing and seeing which direction it should be pointing in. And so that leaves me with the second inequality, r is less than 3. And so 3 is not included in my inequality, but it points to the left, less than. That one stays as it is because the variable is on the correct side. Okay, so I'm looking at values for where my inequality is true for both inequalities. So for this one, it includes -1, and for this one, it doesn't include 3. So r is less than 3, but -1 is less than or equal to r. Okay, so this is the final solution. That's how you write your solution set for the inequality. Okay, I hope that this has helped. If you have more questions, then you can, or you need to practice more. You can also do more of the practice problems. And also, I'm going to do a video that talks about special cases of solution sets, okay? And so we're just going to look through and learn how to read the solutions, okay? I hope this video has helped. See you in the next one.